are you, my friends? This is lecture number 13 of the pre-calculus course, trigonometric functions of angles, and we have to mention something about reference angle. These are the objectives here. Just to remind you here, reference angle is a very important issue in this lecture. Now let theta be an angle in standard position. It can be in any quadrant. It can be quadrant 1, 2, 3, or 4. In this one here, theta is in quadrant 2. So we can draw a triangle. Okay, so this is angle theta. R always positive. To find R, use Pythagorean theorem, R squared is equal to x squared plus y squared. So R is, this is the formula. We can define sine theta will be the y over the R. Now in this case, y can be positive or negative. In quadrant 2, it is positive. Cosine of the theta will be x over the R. Tan theta will be y over the x. These are the three basic trigonometric functions: sine theta, cosine theta, and tan theta. Now on the next slide, I will put the summary of all the 6 trigonometric functions. Sine theta will be y over r, cosine theta x over r, tan theta, cotan theta, secant theta, cosecant theta. Just to summarize, r always positive number, x can be positive or negative depending on the quadrant where theta lies. Let's see example number 1. 3 minus 2, is a point on the terminal side of theta. Let's find the value of 1 over sine theta times 1 over cosine theta plus tan theta. So from this point, we can take x and y. See, x here positive and y is negative. So for sure, the angle here lies in quadrant 4. See, you can just draw a triangle here, right triangle, and find r, because x is positive, y is negative. So you square the whole x here, you square the whole y, r will be square root of 13, which is always positive. Then you can find the functions by using the definition. So sine theta will be y over r, so minus 2 over square root of 13. Cosine theta will be x over r, 3 over square root of 13, and tan theta y over x. Now this is the required. So 1 over sine theta, just the reciprocal of sine, so minus square root of 13 divided by 2, and this is 1 over cosine theta plus tan theta. Tan theta is negative, so I put here minus 2 over 3. Now just multiply here minus 13 over 6. The LCD will be 6. Multiply by 2 here up and down. So minus 13 minus 4 will be minus 17 over 6. Here just to remind you of the signs, S-I-G-N, signs, the positive or negative. In quadrant 1, all the functions are positive, the 6 functions. In quadrant 2, the sign is positive and the cosecant, because by definition, sine will be y over r. I mentioned so many times, r is always positive. In quadrant 3, tangent is positive because tan y over x and cotan x over y. X and y are negative in quadrant 3, so tangent is positive, cotangent is negative. Cosine in quadrant 4 is positive and secant is positive because they are related to x. Now this is the same table here that I explained in the quadrants. You can just read it there. Now in this slide, we see function values of quadrantal angles. These are special angles. We call them quadrantal. 0 degrees, 90, 180, 270, 360. So you have to know the 6 functions, sine, cosine, tan, cotan, secant, cosecant, of these quadrantal angles. You can either use this table, you can just review it, or there's another easy way. You can use the unit circle. See the angle 0, you can use this point, 1, 0. See, x is 1, y is 0. and this is all R1 in all these 3, 4 points on the unit circle. So you can use the definition. Sine will be y over r, and the cosine of this angle will be x over r. Now, in example 2, determine the sines of the 6 trigonometric functions of these angles: 68 degrees, 300 degrees, minus 200 degrees. Let's see the first one. It's easy. 68. See, 68 lies in quadrant 1. So all the functions, sine 68, cosine 68, tan, etc., will be positive. Now for the 300, if you draw 300 in standard position, you see that? So the angle 300, it lies in quadrant 4. You see the complete angle 360. So this is 300 less than that. So it's quadrant 4. In quadrant 4, the cosine and the secant are positive because the cosine is x over r and secant is the reciprocal of the cosine. All the other functions are negative. Now C part minus 200. If you draw minus 200, see, draw minus 200, this is the initial side and this is the terminal side. So the angle lies in quadrant 2, minus 200. So in quadrant 2, the sine and cosecant are positive because sine is y over r and cosecant is the reciprocal of sine, and all the other function values are negative. Same easy question, identify the quadrant. In some questions you have to decide the quadrant given some function values. So let's see here, if we have sine theta greater than 0, this is part A, and tan theta less than 0. So you have to decide which quadrant or quadrants. Now, second one, cosecant theta less than 0 and secant theta greater than 0. Let's see the first one. Sine theta is greater than 0. So which quadrants sine is positive? 1 and 2. Now, if we have tan theta negative cannot be in quadrant 1. So it is in quadrant 2 negative and quadrant 4. So theta lies only in quadrant 2 because we have two conditions there. Now let's see the second one. Cosecant theta is less than 0 and secant theta is greater than 0. Now cosecant theta less than 0 in quadrants 3 and 4 because cosecant is negative here, quadrant 3 and 4. Secant positive will be in quadrant 1 and 4. That's related to cosine, which is x over r. So from these two conditions, we can say cosecant theta less than 0, secant theta greater than 0, theta should be in quadrant 4. Now, reference angle is one of the important topics here. On the left side here, on this left side, I put the definition of a reference angle. Let's see. We have to have an angle between 0 and 360. Yeah, you might ask if we have a big angle, large angle, like 700, 600, etc., you can find coterminal. Now you have to reach an angle between 0 and 360. So it will be in either quadrant 1, 2, 3, or 4. The reference angle, by definition, is the positive acute angle. We call it theta prime or theta dash. These both are called reference angle. So this is made by the terminal side of the angle theta and the x-axis. That's the definition. Let's apply it to one example here. So let's say the reference angle in quadrant 2. Suppose we have an angle like this, 143 degrees. That's theta. So this is the terminal side. You see, this is the terminal side. This is the x-axis. So where's the reference? That's the reference here. Always between terminal and the x. Never use the y-axis here. So this is the formula now. Look at the formula, nice formula. You can find the reference if the angle lies in quadrant 2. it will be 180, see the whole straight angle, minus the theta. Theta is given, 143. This is in degrees. In radians, you can say pi minus the theta. So here you say 180 minus 143 will be 37 is the reference. Now we need the reference to use it in other questions. Let's see now the reference in quadrant 3. Same definition here, same definition. Suppose we have an angle 205. For sure, this angle in quadrant 3. Now, what is the reference? The terminal. This is the terminal side. See this one here, the blue and the X. So that's, we never use this one here. So in quadrant 3, we say the reference angle is theta. See the angle itself, 205 minus 180. You have to be careful when you remember the formulas. Now, the reference angle in quadrant 4. Same definition here. If we have an angle 315, see like this, it will be 315. This is the terminal side and this is the X. So that's the reference here. Remember. So if the angle theta lies in quadrant 4, then the reference theta prime or theta dash will be 360 minus the angle in degrees or in radians. Just a note here, if angle lies in quadrant 1, then theta is the same as theta prime, the same as theta dash, like 75. This is the angle, this is the reference, everything is the same in quadrant 1, remember. Now this is the summary. This is the summary of all the quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4, the same as I explained before, but this is on one slide. Let's find the reference angle of 218 and then the reference angle of 1387 degrees. Let's find the reference for the first one. So we have to decide where is 218. 218, it lies in quadrant 3, right? It lies in quadrant 3. So the reference will be the theta itself, 218, minus the 180. See, this is the formula there. So 218 minus 180 will be 38. So 38 is the reference. See, this is the reference between the terminal side and the X again. Now let's see the big angle here, 1387. 1387 is a big angle. So you have to find first the coterminal until you reach an angle between 0 and 360. Since this is a big angle here, 1387, so you have to subtract multiples of 360, like 1 time 360 or 2 times or 3 times or 4 times. How do you know? You can just quickly divide the angle 1387 by 360, very quickly to know only the number here. So if you divide 1387 by 360, it will be 3.8 something. We don't care about the other numbers here in the decimals. We just care about the 3. That means there are 3 complete cycles inside this angle. If you don't like to divide, you can just subtract. See, 360 times 2 is 720. You can subtract 720. Then you can check the angle. Subtract 360 again, 360 again, until you reach an angle between 0 and 360. So 307 lies in quadrant 4. See, 307 after you subtract 3 times 360 from 1387. So this angle 307, see, this is the coterminal, and the original angle 1387, they both lie in quadrant 4. Let's find the reference. In quadrant 4, to find the reference, 360 minus the theta, which is 307. So 53 here is the reference. Now, from the other examples are coming now, how to use the reference. This is very important question, VIQ. Without using calculators, let's find the exact value of sine 120 and cosine 120. By using calculators, it's so easy. Now, how do you know the exact number, correct exact number, without using calculators? Sine 120, cosine 120. And then after that, you can find many other questions. Let me explain it in one slide. Now look at the steps here. Steps, the quadrant. Step number 1. Step number 2, find the reference. Step number 3, trigonometric value. And step 4, the sign, the plus or minus. So the angle 120, which quadrant? Quadrant 2. Before you start, you say sine 120 is positive, because that's y. See the sign, y over r. The cosine is negative. So at least we know this is a positive number. This is a negative number before even we find it. Now, second step, find the reference of 120. 120 in quadrant 2. So it will be 180 minus 120, which is 60. Now, sine theta, either we take plus or minus, according to the quadrant, sine theta dash. So we use the sine 60 for the first one. We use cosine 60 for the second one, but we have to take care of the sign. See the sign here of 120, we said positive, so we say positive here, plus sine the reference. See, sine theta is equal plus or minus sine the reference. You can just remember that. And we know sine 60 will be square root of 3 over 2 and positive, so that's the answer here. Now let's see the cosine. Cosine 120, which is cosine theta, plus or minus, it's minus, because the cosine, which is the x value in quadrant 2, it's minus, so minus cosine 60. Cosine 60 by itself, which is the reference, is half, so that's minus half for the cosine. Now see the general rule on the next slide to see more complicated questions like example 5. This is the general rule here. I mentioned that general rule will be just take a theta. If the theta is greater than 360 or less than 0, that means either very big or less than 0 negative, find the coterminal. After that, you find the reference, theta prime or theta dash. Then you find the trigonometric function values of the reference. Then you choose the sign, the correct sign, in which theta lies. Remember, in which theta lies, the angle, the theta, the given. Let's see 3 questions now. Really nice. Tan 510, sine squared 1020, cotan of minus 855. Please try to understand these 3 parts, and you can do many other questions similar. Let's take the first one, tan 510. Now, as I mentioned, the steps are 510 is a big angle, so we have to find the coterminal. So let's subtract only one complete cycle, subtract minus 360, it will be 150. So 150 here lies in quadrant 2. So in quadrant 2, the reference, remember reference 180 minus the angle 150, it will be 30. So tan 510. Now, tan positive or negative, tan in quadrant 2 is negative, so we write tan theta, remember here what I said? Tan theta is minus from quadrant 2, tan the reference, and the reference is 30, and we know tan 30 will be, this is the minus from the quadrant, half the sine of 30, cosine of 30, square root of 3 over 2. Either you write the answer minus 1 over square root of 3, or you can rationalize it, so it will be minus square root of 3 over 3. That's the first one. Similar way, you can do B and C. You can pause the video if you like here, try it, and then you can check the answer. Remember here, there's a little trick here in the squared. Sine squared 1020. You can have here also tan squared. See the squared, you can take it outside, so it will be sine 1020 all squared. So after you find the value, all of it, and then you square it. Here, remember, this is B part. Sine squared of theta is equal to sine theta all squared. This applies to all functions. Cube squared power 4. So 1020, we find the reference. We can subtract 2 complete cycles. So 1020 minus 7. 20 will be 300. 300 lies in quadrant 4. So find the reference, 360 minus 300, which is 60. So the sign, see here, sine 1020 is minus. In quadrant 4, the sign is minus sine 60. This is the reference. So minus square root of 3 over 2. That's only sine 1020. But we have squared. If we have a squared, we find the value inside, see, which is a minus, all squared. So 3 over 4 is the answer. Now, maybe they will ask you, find sine 1020 only. So you have to mention the minus. Now, in the squared, the minus will disappear because you square it. But only if you need the function sine 1020, it will be minus square root of 3 over 2. Let's see the last one, cotan of minus 855. Now, minus, angle is negative. We have to find the coterminal to know in which quadrant. So you have to add here multiples of 360. So you add 360 or 720, whatever. So here we add 3 times complete cycles. So 3 times 360, that's a positive number here, add 2 minus 855 will be 225. So this is the angle now. So the angle lies in quadrant 3. So the reference will be 225 minus 180, which is 45. So cotan of minus 855 in quadrant 3, remember, if you remember, the cotan is positive in quadrant 3. So you say positive. Cotan, the reference. Cotan, the reference, cotan 45 is 1. So plus 1 here. Even if this angle is minus, it lies in quadrant 3. Now, this is a summary of all the formulas that we had in this lecture. Just remember here, tan squared of theta, tan theta all squared, or you can have sine or cosine or secant or any power. See, the power on the function means the power here on the whole function. And we know these formulas, reciprocal, quotient, Pythagorean identities, sine squared theta plus cosine squared theta is 1. 1 plus tan squared theta is secant squared theta. 1 plus cotan squared theta is equal to cosecant squared theta. Let's see a nice important question here. We have given tan of A minus 2 over 5 and sine of A greater than 0. Let's find secant of A plus cosecant of A. See, given the tan, I have mentioned before in other lectures, given any function, trigonometric function, the value there, any one, and with the condition here to know which quadrant, then you can find the other functions. So let's start here. So tan here is minus for sure, minus 2 over 5, it's negative. And sine A, positive. So the angle A here, this angle lies in quadrant 2. So in quadrant 2, x negative, y positive, remember. So x related to cosine and y related to sine. So tan A now, I have to put the minus here, minus 2 over 5, 2 over minus 5. Why? Because I know in this line here, x is negative, and we know the formula for tan theta, that's, remember, the formula y over x. So y here is 2 and x is minus 5. See, this is the angle here in quadrant 2. So x is negative, y positive. These numbers are the same, minus 2 over 5, the same number as 2 over minus 5. So let's find r. Remember, r always positive. You square root of x squared plus y squared. So square root of 29. Now, from the last slide, we see that r is equal to square root of 29, y is 2, x is minus 5. So we can find sine A y over r, 2 over square root of 29 and cosine A x over r minus 5 over square root of 29. We need secant of A, which is the reciprocal of the cosine. So square root of 29 over minus 5. I can put the minus up or down. Plus cosecant of A, the reciprocal of sine of A. It will be square root of 29 over 2. The LCD here is 10. So that will be 3 square root of 29 over 10. Now we see here two important remarks. If tan theta is given, and you need to find sine theta, cosine theta, put tan theta y over x, and then find r, because sine theta will be y over the r, cosine theta x over r. See example 7, the one before this slide. This is very important. And if sine theta and cosine theta are already given or we know them, then you can use formula number 4 to find tan theta, sine theta over cosine theta, to find tan theta. All right. Now express tan theta in terms of sine theta where theta lies in quadrant 2. Now we don't know a formula that relates tan theta and sine theta. We have to find it now. So we start, this is the question here, express tan theta in terms of sine theta. I start with the quotient identity number 4, tan theta sine theta over cosine theta. There's a condition here, theta in quadrant 2. So I need tan theta is equal something in terms of sine theta. So I have to remove this cosine theta. So I go to Pythagorean identities. Sine squared theta plus cosine squared theta is 1. So I find cosine squared theta 1 minus sine squared theta. Take the square root of both sides. So cosine theta will be plus or minus this one. Now theta lies in quadrant 2. So the cosine is negative. So I take here the cosine with minus and put it in the denominator here. See, that's a minus square root in the denominator of this. So what is tan theta now? Tan theta would be the minus. I can put the minus in the denominator or in the numerator. It looks better here. So tan theta will be minus sine theta divided by square root of 1 minus sine squared of theta. That is the answer. This is tan theta in terms of sine theta only with some numbers. Now, these are some questions. I will leave it for you to try. We have a point minus square root of 3 minus 2 on the terminal side of angle B. Find the value of sine B times cosine B plus cotan B. So there's some questions here. Given tan, see here, given tan theta, square root of 13 over 3, such that cosecant theta less than 0. Find the value of sine theta times tan theta plus cosine theta. Find the reference angle of minus 860 and find the reference angle of 8 radians. Maybe a little tricky. Find the exact value of this. Sine minus 510 times cosine 300 plus square root of 3 times cotan minus 210. This is similar to the example we did, but we did it, each part is separate. So you can find the first value, second value, third value, then you can multiply and add. Question number 5 is only about signs. Which one of the following statements is true? We have cotan of this angle minus 100 is negative, sine 370 is negative, secant minus 89 is positive. So this is the multiple choice, A, B, C, D, E. 1 is true and 4 are false. If alpha is the reference angle of 675 and beta is the least positive coterminal angle of minus 240, find alpha plus beta in radians. So you have to find the reference here, you have to find the coterminal, then you have to convert the sum here, alpha plus beta, into radians. Express secant alpha in terms of sine alpha, where alpha lies in quadrant 3. This is similar to the last example we did. So you have to find here, you have to generate, you have to find a formula for secant alpha is equal something in terms of sign only with some other numbers. Now, these are the answers of the 7 questions. See the last one here, secant of alpha. It will be -1 over square root of 1 minus sine squared of alpha. Now you have to know how to find that. Now for the complete solution, please, of these questions, you can visit the video on trigonometric functions of angles. Also, there's a reference angle, lecture number 13, pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is pre-calculus course, lecture number 13. I hope I can see you in another video with another topic. Thank you very much.